In this tutorial we're going to focus on refraction in the topic of light. Refraction is a phenomenon that's observed when light passes from one kind of medium through another. By a medium we mean some kind of substance like air. Air is a medium, or water. Water is a different kind of medium. Or glass is a different kind of medium. So when light passes from one medium, say something like air, as shown here, into another medium, for example this glass prism is shown here, then something happens to the light. So if we look at this photograph carefully, we can see a light beam being shone from air into a glass prism. When it hits the glass here, you can visually see that the light bends. Then when the light comes out of the glass on the other side, back into air, you can see it changes direction again. This bending of the light as it passes from one medium into another, or out of one medium into another, is called refraction. So we would say that the light has been refracted. Let's take a closer look at what's happening here in the physics of refraction. So in this diagram we have it drawn what was really shown in the photograph a minute ago. So we have an incoming light beam, so the incident ray is being shone from the medium, which is currently, let's say, air, but it doesn't have to be, but let's say it's air, into a medium, in this case let's call it glass, or it could be water. So as the light beam hits the surface, or the boundary, between medium 1 and medium 2, say the air and the glass, we can see that the light beam refracts or bends inwards. This angle in here is described as the angle of incidence. Just like in reflection, when you're trying to calculate the angles, you draw in an imaginary line called a normal, which must always be at 90 degrees to the surface. So we have a normal there and we have a normal here. Then you can see the refracted ray, that's the light ray that's bent, and the angle between the refracted ray and this normal is called the angle of refraction. Now, unlike reflection, where the angle of incidence always equals the angle of reflection, in refraction the angle of incidence, as you can probably even see visually, does not always equal, does not equal the angle of refraction. That they are different because the light is bending as it moves through the second medium. When light comes out the other side of this medium, it returns to its original angle, the same as the incident ray. Let's finish off this short tutorial by looking at why the light bends as it passes from one medium into another. So, if we have a glass prism here, so let's say this is glass, or it could just as well be water in a glass, a cup of glass, and let's say this medium's air, and we shine a light beam through the air, hits the glass, and it bends and it comes out the other side. So the light refracts as it passes through the glass. Why does it do this? Well, remember, light is travelling at very close to 300,000 kilometres per second. When light passes into a medium that is more dense than the one it's already travelling through, now by density we mean how much material is packed into a certain space. So glass, for example, is more dense than air. There are more particles packed into the space occupied by the glass than there are particles packed into the same space in air. So glass is more dense than air. If you like, it's kind of thicker. Then it's a bit like a person diving from the air into a pool of water. You meet more resistance and therefore you naturally slow down. It's much harder to move through water than it is through air. Well, it's the same for light. If light's travelling at 300,000 kilometres per second through air, when it hits the glass, although the light can pass through it, it slows down. So instead of continuing straight ahead at the same speed, it actually bends inwards. And when it comes out the other side from glass back into air, it will speed up again because it's moving from a more dense medium like glass back into a less dense medium, air. So it speeds up as it comes out the other side. So this is why light refracts as it passes through different kinds of medium. In this slide we can see refraction working in real life. So in this example here we've got, if you put a pen or a pencil or paintbrush into a glass of water, you can see that it appears to almost be broken or bent at the surface. And we see that this is that phenomenon of light being bent at the surface of the water, between air and water, and hence creates this optical illusion that the pencil actually looks broken or bent. We can see that here. Here's another example that you've done in class when you shine a light beam into a triangular prism, a piece of glass here. That light gets bent as it goes through the glass and actually gets broken up into its different component colours in the spectrum. So refraction is happening in this case as well. Here's another kind of classic example of refraction when an observer is looking at an object underwater. So the observer is out here in the air, and there's an object like a fish in the water. Let's say the fish is actually here, but because of the bending of the light at the surface between the water and the air due to refraction, the observer sees a virtual image, an apparent image of the fish here. So in a kind of a straight line on from where their line of vision. But because the light's actually bending, the real fish is actually down here. So if you were spearfishing, for example, if you aimed at the fish you could see, that's this one, you would miss it. And so you have to allow for this kind of bending of the light to estimate where the real fish actually is. Alright, to finish off the tutorial, let's just have a quick look at the explanation for why when refraction occurs, we again see objects closer than they are, that is, they look magnified, and they are often in a different place to where we think they are. So because of refraction, our eyes basically and naturally, so if we're looking at an object in water, let's have a look at this diagram on the right. So this is our eye and we're looking down at the fish. Our eyes naturally, or our brain naturally interprets light coming to it in straight lines. So although the fish is actually here, because the light bends at the surface here, our brains interpret that the fish is here. This is the apparent fish, or the apparent depth of the fish. So to our brains it looks like the fish is actually here, even though in reality the fish is down here and deeper, further away. So the real depth of the fish is where the fish actually is in the water. The apparent depth is where our brain perceives that the fish is, based on the light being extended out in a straight line rather than being bent by refraction. So the apparent fish, the virtual fish, this one here looks closer, therefore it looks bigger than the real fish, so it's magnified, and it's in a different place to where the real fish actually is.